Okay, thank you for introducing me. So I will only add that those slides are available on this short link, bit.ly AWI18N. And let's start. Before talking about internationalization, let me describe what the internationalization is. It is abbreviated I18N because there are 18 letters between I and N, and it means supporting for multiple locales in the app code and design. Basically, for example, it means not hard coding text in the Kotlin code, but using the resources mechanism, or designing your composables that they not break when the translation is 2 times longer than English. There is also a localization, L10N, which means providing the localized assets resources like text and images and so on. And the internationalization is for multiple locales, not languages, because the locale contains not only language, the language is mandatory part of the locale, but the locale can also contain region. For example, English is a little bit different in the USA and in the Great Britain and in the Australia. The locale can contain also script, the alphabet, or other kind of writing system used by the given language. For example, in case of Serbian, we have Latin and Cyrillic alphabets. And there are also other properties like which calendar to use, which numerals to use, because locale is not only for text, but also for numbers and dates. Let's start with the most commonly localized type of entity is there are strings, text. You place them inside the res directory, and there are subdirectories for the given locales, for the particular locales supported by your app. The default locale, unqualified, is in the values subdirectory, and you can create as many subdirectories as many locales you support. For example, this one is for English, and this is for English used in Australia, and this is using slightly different notation, is for Serbian with the Latin script. And note that you cannot pass the script in using this older notation. This supports only language and region, and you cannot pass only region. Language is mandatory here. Also note that you don't have to translate every string to every locale, even if your default locale is, for example, French, and you have English translations. There still may be some proper names, company names, and so on, which are not translatable to English. So you can keep them only default values folder. Translate, which is translatable to English in this values en, and only the string specific to Australia you can translate here. If there is no given string in this file, the English without region will be taken into account. By convention, the file containing the strings, so it's called strings XML, but you can use any name or even split those items into many files. Only values, only content matters, not the file name. And there is an optional resource properties file. It contains information in which locale is these unqualified values translations. In this case, we have French. FR stands for French language code. And it is important because starting from Android 13, we have per app language chooser. So we need to know which language to display for this default locale. So this FR is used here. User can choose French. To generate a list of those locales, if it just have to contain all the locales supported by your provided here in your res directory, you can use this generate local config property set to true, and don't forget to provide this file. There is also a tools locale attribute in the unqualified resource folder in the XML files in this folder. It is used, for example, by spell checkers in Android Studio and lead static code analysis. If you look here, you may notice two strange languages here. What are they? Those are pseudo locales used for testing your app if it supports localization properly. To enable those locales, set to is pseudo locales enable flag to true. Usually you may want to enable it only in the debug build type. You don't want they to show in their production releases. And this is the English and in non-existent country XA. It is built out of the default language. It has nothing to do with the normal English. And how it is built. To the default translation, there are additional words appended to simulate longer translations in some languages. There are also square brackets at the beginning and the end, so we can easily check if a string is not cut horizontally, if it's contained in your layout. And also there are accents, diacritical marks on the top and on the bottom, so you can check if lines are not cut vertically. And pseudo-Arabic is just a default translation, but written backwards. And also the layout direction is right to left. For example, this back arrow is right facing, not the left facing, like in the plain English. And this pseudo-Arabic is slightly different than enabling the force RTL direction developer settings, because it does not place the letters backwards. It only changes the layout direction. And there is also one more property in the build script. It is called resource configurations. You can add a list of configurations, not necessarily only locales, but here, for example, we have a port, which stands for portrait, screen orientation, portrait versus landscape. And only resource configurations added here are preserved when building your app. Every other configuration which does not match, for example, landscape in this case, and Japanese, Norwegian, and so on, are stripped, are not taken into account when building APK. Okay, but why there is such property? Why there is ability to list such supported configurations? So if my app supports only English, French, and portrait, I just don't provide Norwegian, Japanese, and landscape. Why do I need to strip anything? Well, even if you do not provide resources for such configurations, the external libraries may provide. For example, I appended the Android X libraries, and they added over 100 string resources across 87 configurations, and it increased the APK or AAB size. And there is one more implication. Let's imagine that the user hasn't switched this per app language. It has system default, and the app supports languages like here, English and French, which is the default. But your user has a Japanese set on his phone. What will happen? Your text from your app will be displayed in French because this is the default language. There is no best match. But the text from the Android X library will be displayed in Japanese because they are provided. This will be inconsistent, and this may be not what you want. The strings may contain placeholders, and those placeholders may be numbered. Let's take this real one example from the Android open source project code. That network has switched from one operator to another. In English, the old operator is at the first place, and the second operator is the second place. The new one is here. But for example, in Tagalog language used in Philippines, the new operator is at the first place, but the old operator is at the end. And Tagalog is written from left to right, like English. It is not right to left like Arabic. Only the grammar rules says that the new operator should be at the first place. By using this number, you can keep your Kotlin code the same. So the first argument is always the first placeholder, no matter where it is physically positioned in the given translation. Sometimes only placeholders using only placeholders is not enough because there is some plurals. Some word may be pluralized. Let's say in English we have one attempt, but 2, 3, 4, 5 attempts. There's a plural here, one and other quantities. In some other languages, there may be one more quantity clauses. For example, in Slovak, we have 4. In Arabic, we have 6. There is a case for 0 as well. And keep in mind that 1 does not necessarily mean exactly 1. It may also mean 11, 21, and so on, depending on the language. Lint will throw an error if you don't provide the necessary quantities for the given language, and will throw a warning if you provide too much quantities, some not used in the given language. And in case of plurals, there is one additional argument. The first argument is always an integer. It is only used to choose the correct class. And next we have placeholders, and they may be more than one placeholders in the plural, and those containing the pluralized number may not be the first. Like here, this is the first placeholder. It is here. The second placeholder is here, and this argument, it is a count used to choose the correct quantity. Here D stands for integer, F stands for float. It can also be used in locale. This is the same rules as in the string format method in Kotlin. And there are some basic formatting options. For example, you can write .2. It means to include 2 decimal places, 0 padded if needed by default, and there are 6. And this comma means to apply the local specific number formatting. Let's say in English we have dot as decimal separator and comma as thousand separator, but in German there is an opposite. But in Germans used in the Switzerland, the separators are different. Note the difference between French and Polish. In Polish you have white space, normal but no breaking space, but in French it is a thin space. In case of Arabic, we have different numerals. This is Marathi, used in India, for example, has yet another numerals. Phone numbers are also localizable, but the format does not depend on the display language of the user interface. It only depends on the country of the number and type of the number, whether it is landline, mobile, special, toll-free, and so on. Let's take a look at this Polish number. There are 9 digits, but this one is landline. It has 4 groups. And this one also has 9 digits, but it is mobile, so it's grouped differently. In France, the same number is yet another grouping mechanism here. If you don't provide the international prefix with plus, this country from the second argument will be used as a country code. There are 2 most popular ways to format phone numbers. Phone number utils class, it is in Android SDK, note the plural here, and the phone number util from the libphone number library maintained by Google. This library has more options, has more powerful API. You can format the number in more ways. And it is frequently updated because across all countries, all the world, there are updates almost every week to numbering plans. New number ranges are added constantly. These
phone number used in the Android SDK is as old as the Android OS on the device, so maybe few years old. Everything else inside the res directory can be localized. For example, drawables, images, especially if they contain some texts or prices. Raw resources like video files if they contain subtitles or speech, as well as sound files. And everything else inside the res, every type of resources can be localized if needed. Apart from the language and region, there is a special kind of qualifier supported by Android. It's called MCC. MCC states for mobile country code. It is a country code of the SIM card or other kind of subscription on the first slot. So in case of the multi-SIM, dual SIM devices, only the first SIM card matches. And if device has no radio or no SIM card, then it won't work. And what is important, this MCC takes precedence over all the other rules. So for example, if your app supports Japanese, the user has Japanese set as the language, but they have this MCC from the USA, then those values will be taken into account, even if you don't provide anything to the region, to the USA region by using the R suffix in the name. There are some drawbacks also in using this MCC. For example, some countries can have multiple MCCs. User can have like SIM card from another country, especially in Europe when we have Roam like at home. If you are more interested about falsehoods programmers believe about phone numbers, I recommend you this article, which is linked here. It's on the lib phone number documentation page. What else can be localized is the legal stuff, terms and conditions, and the related layouts, opposables, and so on. For example, in some countries, it may be enough to just take the implicit consent from the user. So by using this app, you agree to the terms and conditions, and you don't need to check anything. But in some cases, especially in the European Union, when you have GDPR and apps processes some personal data, the users have to tick explicitly a checkbox, and this cannot be ticked by default. Of course, this version without any checkboxes can have higher conversion rate, so it's preferred by marketing. So we made to differentiate the layout depending on the country. Take a look how numbers can be localized. Here's an example number for 6 and 12 zeros. In case of English, it is 6 trillion, but in French, the same number is 6 billions. French has a word for trillion, but it's a different number. It has trillion in French, has more zeros, not trillion in English, because French is using different scale for numbers than English. There are also some other formatting options like short, engineering, and simple without using only numbers without any text. This is for Arabic, and you may notice it has a different numerals here. Formatting numbers with percents can differ across the locales. For example, in Polish, we have just number and percents without any additional characters. But in French, there is a space here. This is a Basque language spoken in Spain. Despite that, it is left to right, like English, but the percent sign is at the beginning, not at the end. And in Arabic, we have a different percent sign despite of different numerals. Okay, take a look at the dates. Here's the today's date, and Polish and English example. There are many different things. Separator of the date elements, dot versus slash, leading zeros. Order of month and day is different. A year is written using 4 digits here, but 2 digits here in English. 24-hour clock versus 12-hour with AM PM. I recommend using the predefined formats, for example, short, long, and so on. But if you need to customize the patterns, keep in mind that there are two forms of mode. L, which states for standalone mode, for example, using here without any day, and M, normal mode, which is near the day. In English, they are the same, but for example, in Polish, they differ. It is an error to use the invalid form. Even list formatting can differ across the locales. In English, we have comma as a list item separator, but in Japanese, there is another separator here. Date ranges also differs not only by formatting the individual elements of the date, but also separators of the first and last range element. For example, here in Latvian, we have not hyphen, not minus, but n dash is slightly wider. But in Japanese, there is another separator. Here in Spanish, in Colombia, there are no separators at all, but only words dividing the dates. In case of currencies, the format of the numbers depends not only by the locale, but also by the currency. For example, the Polish zloty or US dollars have 2 decimal places because there are 100 cents, but some currencies like Tunisian dinar have 3 decimal places. You can also combine the precision and compact form, notation form, like compact or not, into the number formatting. And let's go back to the right to left, the layout direction. Some languages like Hebrew or Arabic are right to left, unlike English, which is left to right. And take a look at this text. This is a translated hello world to Arabic, and the exclamation mark is here. This is the last character. This is the first one. So the order of letters is different. The order of the entire layout is different. And also the drawables, which are pointing some directions, are mirrored. This is a back arrow. It is right facing, not left facing. Also, all the transitions animations should be mirrored. This back arrow is also mirrored. But for example, those arrows here, this shield, are the same because they are purely decorative. They don't represent any direction in navigation. To use those icons in composable, which are mirrored, you don't have to provide your own drawables or mirror it programmatically. Just use auto-mirrored icons in Jetpack Compose. In case of your own drawables, you can set the auto-mirror property attribute to true. If you have, for example, the bitmap like PNG or WebP, you can wrap them with bitmap and set this auto-mirrored attribute to true here. Okay, where to perform localization? Somewhere at the data layer or the view model, or maybe on the UI layer? And the correct answer is on the UI layer. Why? Mainly because if the configuration changes, for example, the user switches the language of the device when your app is running, the view model will survive this configuration change. It will not recreate, but the UI layer will be rebuilt. It will be destroyed and new one will be created. So the UI will refresh, and if you are performing localization on the UI layer, then you will get the correct text. But if you perform the localization on the view model level, they may be outdated in this case. And also most of the, maybe not most, but many of the methods providing localized resources require context, Android context. And it's usually a bad idea to pass the context to the view model. If you want to read more about localization and internationalization, you can use those articles. The first ones are the official Android docs. The next ones are my articles on the blog. And here's the mentioned falsehood about phone numbers. Those slides are available under the short link or this QR code. And that's all. Thank you for watching. If you have any questions, you can find me on this email or on Twitter, on LinkedIn. And if you have any feedback, what was great, what was wrong, you can use this anonymous feedback form. Yeah. And that's all. Thank you for watching, and it's time for Q&A.
Thank you so much, Karol, for this insightful session. I must say that I have seen other developers having some utility functions to handle those functionalities. Even in my own application, I remember having the util function for handling currency for French and English, which can be handled in this way as well. So thank you so much for this. And we don't have any questions from our viewers, but yeah, it's actually a very, very great session.
Okay, so thank you, and see you on the next editions of the Android Worldwide.